All right, congratulations, you made it past objective 3. That's definitely the hardest objective from this unit when we were dealing with the rational expressions. Now we're solving rational equations in objective 4. This one's a little bit easier. And here's why. If I just have a fraction, well, we did that last time. Let's look at what we're doing today. Why are the equations easier? If I have an equation like 2 equals 2, okay, keep it real simple. Well, what can I do to an equation? Can I add 3 to both sides? Plus 3, and then I get 5 equals 5. Is this a different equation? Well, sure, but it's still a true statement. Here I had this is a true statement. Now this is still a true statement. Can I divide both sides by, I don't know, let's say 4? And then I get 5 fourths equals 5 fourths. Is that still a true statement? Sure. So the point is, if I have an equation, what can I do to my equation? Well, anything I want. So when I get an equation like this, we can do something to it to make it easier than it looks currently. Okay, but if we have an expression, which is, if there's no equal sign here, well then, I can't multiply both sides because there are no two sides. It's just those things, and I have to get a common denominator and do all that stuff. Okay, but like it says up here, the key to solving a rational equation is to clear the denominator or clear the fraction. Let's say clear the denominator. Okay, or sometimes, since we don't like those fractions, you might even want to say we want to kill the fraction. In other words, I want to get it so that my problem doesn't have any more fractions, because that's going to be easier to solve. Okay, and then like it says here, we do this by multiplying every term by the least common multiple of our denominators. Okay, so the key for number 1 is to multiply everything by what? Well, what's the least common multiple between 5 and 3x? Okay, now we can always get a common multiple by multiplying these two things together. Okay, that will always give us something that will work. It's just not always the smallest thing that will work. And if we don't use the smallest thing, that's creating more work at the end, because then we have to do a bunch more reducing. Okay, now another thing, if you're having trouble trying to figure out what to multiply by, let's zoom in here a bit. I can always just do it one fraction at a time. What's going to get rid of this denominator? Multiplying by 5. What's going to get rid of this denominator? Multiplying by 3x. But again, we want to try to do something that's going to get rid of both things at the same time. And what's going to get rid of both these things at the same time? Well, this one, since they don't have anything in common, it is their product, which is 15x. So for this first problem, the key here is we want to multiply everything by 15x. Now that doesn't mean just do the fractions. We got to multiply everything by 15x. Okay, let's rewrite our problem so we have a little bit more space. So we got 3 over 5 plus, and we'll leave a little bit of a gap, 6 over 3x equals a little bit of a gap, 3. Okay, and then I want to multiply everything by that LCM, which is 15x. So I want to multiply each part by 15x. Okay. All right, so when we multiply by 15x, what are we left with? Well, here, the 5 and the 15 reduce to give me a 3, and then 3 times x times 3 gives me 9x. So now I just have 9x instead of a fraction. Here, the x's reduce, and the 3 and the 15 reduce to give me a 5. 5 times 6 gives me 30, so plus 30. Equals, and here there's nothing to reduce, it's just 15x times 3, which gives me 45x. So after one step of multiplying by something, well, now we have an equation of no fractions. This is going to be easier to solve. Okay, let's start by subtracting 9x from both sides. And then we'll bring it up here where we have some space. That gives us 30 equals 45x minus 9x gives us 36x. And then if I divide both sides by 36, to get x by itself, so those reduce, and we get x equals 30 over 36, which reduces to 5 over 6. Okay? And then that's our answer. Okay, now, something that we don't want to do on every problem, since we're solving an equation, nice thing about that is we can check our answer by plugging it back in. Okay, will this answer make this equation come out true? Well, if we did our math right, then it should. Let's check. So we got 3/5 plus 6 over 3 times 5 over 6 equals 3. So we want to see, is this true? Okay, so let's see, that's 3/5 plus 6 over, and then let's see, the 3 and the 6 are going to reduce to give me 5 over 2. Okay, and then we haven't dealt with complex fractions yet, but just think of it this way. If I multiply the top and bottom by 2, that's going to give me 3/5 plus 12 over 5 equals 3. Okay, and then that worked out nice because now I have a denominator of 5. So again, what I did there was multiply the top and bottom part of my fraction by 2, which we can do that because 2 divided by 2, 2 over 2, sorry about that, is 1. So really we just multiplied by 1. So anyways, this is good. And then 3/5 plus 12/5 gives me 15/5. And then is 15 over 5, does that equal 3? Yes, it does. So we know we did our math correctly. Okay, now, first of all, it's not always going to be this difficult to plug in. You're not always going to end up with a fraction like this down here. I just did that to show you that, yeah, our answer does work. Okay, so again, if you're working with equations, one nice thing about that is you can always plug in your answer to check to see if you did it right. Okay, anyways, that's number 1. Number 2, another equation with some fractions in there. So then what can we multiply by to get rid of those fractions? Let's see, I got to multiply by an x to get rid of this fraction and that fraction, and I got to multiply by a 4 to get rid of that fraction. So then I want to multiply by both those things, which is 4x. So our key here, we want to multiply everything in this equation by 4x. That's going to get rid of all my fractions. I'm going to rewrite it again so I have more space to work. So we got 5 over x plus 7 over 4 equals negative 9 over x. Okay, and then like we said, we want to multiply everything by 4x. Okay. All right, and then next, what do we get when we multiply everything by 4x? Well, here the x is reduced, and I just get 4 times 5, which is 20. So no fraction there, that's good. Here the 4 is reduced, and I get x times 7, which is 7x. No fraction there, that's good. And then here the x is reduced, and I get 4 times negative 9, which is negative 36. Okay, now we got a nice equation, no fractions. This is going to be easier to solve. Let's start by subtracting 20 from both sides. We'll bring it up here. And that gives us 7x equals negative 56. And then divide both sides by 7. And we get x equals negative 8. So this one, not a fraction, would be much easier to plug in and check. But again, we don't need to plug it in every time. But if you're not sure about your answer, or if it's on the test where your questions are worth a lot of points, then it would be worth it. Okay? But again, you don't have to plug it in every time if you don't want to. Now, one thing you do want to check for is this answer okay to have? What's the only answer that I can't have for x in this equation? Well, I can't have x equals 0 because then I'd have 0 in the denominator. Since this is not 0, yeah, we're good with that answer. And again, you can plug it in to check, but we won't waste time on this one here. Okay. Example number 3. Here, what do I need to multiply by to get rid of all my fractions? Well, I got to multiply by a 2 to get rid of that. I got to multiply by an x minus 1 to get rid of that, and that one. Okay, so good. I got to multiply by a 2 and an x minus 1. So let's see, I'm going to rewrite this again. We got 3 over 2 plus, I'm going to leave a gap, 4 over x minus 1 equals, and leave a gap, x plus 1 over x minus 1. Okay? And then the way we want to solve this is by multiplying everything by the LCM of my denominators, which is 2 times x minus 1. So a lot of these problems require a lot of writing, but hopefully they're not too difficult. All right, so here the 2's are going to reduce, and I'm left with x minus 1 times 3. If we distribute the 3, we get 3x minus 3. So no more fraction there. Awesome. Here the x minus 1's reduced, and I just get 2 times 4, so that's going to be plus 8. Equals, and then here the x minus 1's reduced, 2 times x plus 1 is 2x plus 2. All right, so again, here we have a equation with no fractions. This is going to be a lot easier to solve. Let's start by combining like terms. 3x minus 3 plus 8 is 3x plus 5. And then that didn't change over there. All right, next I'm going to do two things. I'm going to subtract 2x from both sides. And that's good. I'm going to end up with just 1x over here. And then since we're bringing the x's to the left, let's bring the numbers to the right. Let's also subtract 5 at the same time. And then that gives us x by itself, and then that's gone. And we get equals negative 3. And again, we can plug this in and check to make sure it works, but it does. I won't make the video any longer than it needs to be. And last thing real quick, is this an acceptable answer? Sure, what's the only thing the x cannot be? Positive 1, because that would give us denominators of 0 in our original equation. Okay, so negative 3, we like that answer. All right, last one on the front page. All right, so this time I've got x minus 1 over this mess plus this fraction equals that fraction. Okay, so then what do I need to multiply by to get rid of my denominators? Well, x plus 1 and x plus 2 and that whole thing. Okay, but maybe we don't need to multiply by that whole thing. We don't like it in standard form. Let's write this thing in factored form, and then maybe it'll be a little bit nicer for us. I'm going to scoot over to the left where we have plenty of space to work if we need it. So we got x minus 1 over, and then I want to write this in factored form, which this in factored form is going to be x plus 2 times x plus 1. Now, always check it, but usually if you're given something that's in standard form and then 2 factors, usually this is going to be this times this. Okay, not always, but so check it. But that might help you factor. Think, okay, it's probably these two things. Does that work when you multiply these? Do you get that? Yes, you do. So x plus 2 times x plus 1 plus 2x over x plus 2 equals x minus 1 over x plus 1. Okay, now I gave myself some space here because what do we need to multiply by now to get rid of all these denominators? I got to multiply by an x plus 1 to get rid of that, and I got to multiply by an x plus 2 to get rid of that. And if I multiply by an x plus 1 and an x plus 2, well, that's going to get rid of both these parts as well. So then that's what we need to multiply by, is x plus 1 times x plus 2. Now again, there's a lot of writing here, but everything's going to work out pretty nice. You'll see in just a second. So we want to multiply by x plus 1 times x plus 2. Okay, so again, a lot of writing, but this is the nice part. Here, the x plus 2's cancel, and the x plus 1's cancel, and we're just left with that, x minus 1. So no more fraction, good. Here, the x plus 2's cancel, and we're left with 2x times x plus 1. So if we distribute the 2x, we get 2x squared. That's going to be positive 2x squared plus 2x. Equals, here the x plus 1's cancel, and we get x minus 1 times x plus 2. So this one you need to FOIL out because, again, this is a binomial times a binomial. And here you would get x squared plus 1x minus 2. Okay? All right, so this one's a little bit different because instead of a first-degree equation, now we got a second-degree equation, which means we're going to get 2 answers. Okay, and then we just want to make sure that both of our answers work, because what answers for x can we not have? -1 and -2. Okay? All right, so let's see. We want to get our x's on the same side of the equation. I'm going to bring my x's to the left because that way my x's stay positive. So I'm going to subtract x squared. Let's also subtract x. And in fact, we want to set it equal to 0. So we're going to add 2 as well. Okay, now be careful because there are several parts with x in it. And what are we left with when we do this? And I'm going to put my answer, well, I'll put it right below so we can see it on camera. First of all this stuff is gone. Don't need to worry about that. Okay, my x squared terms are right here. 2x squared minus 1x squared leaves me with 1x squared. And then I've got 2x minus x, but I've got another x over here. So in fact, let's just do x here minus x. Those pretty much cancel each other out. Let's just get rid of those. And I'm left with just the plus 2x. And then the numbers, I've got -1 plus 2 gives me plus 1 equals 0. Okay, so now we're left with this quadratic equation, and now we can solve using the quadratic formula, or we can try factoring or different methods. Let's do this one by factoring. Okay, hopefully that's something we're getting better at now. So if we factor this thing, we're going to get two binomials, set equal to 0. Our signs are the same and they're both positive. Got to have x and x to get x squared. And then what multiplies the 1 and adds up to 2? 1 and 1. Okay? So the one answer that we get, and we get it twice, is x equals -1. Okay? So is this our answer? No, why not? Well, because x can't equal -1, because that would make that have a denominator of 0. So then that one's no good. This one, our answer is no solution. Okay, so we always want to check to see is the answer we got by solving one of our excluded values. In this case it was, so then we have no solution for an answer. Okay? All right, getting close to being done here. A couple more in the back. Okay. All right, so this is just kind of reminding us what we talked about on the front page. Remember, the key to solving these ugly fractional equations is to find the LCM of our denominators and use it to clear the denominator or kill the fraction, whatever you want to put. I like kill the fraction. Okay. All right, so example 5, and we're almost done here. There's just two more. Example 5, we got this fraction equals that thing minus that thing. Okay, now, what's the LCM between these three denominators? Well, it's hard to tell when we have something in standard form, so the first thing we want to do is write this in factored form. So let's see, we got 6 over x minus 3, that's fine how it is, equals 8x squared over, and then x squared minus 9, that's a difference of two squares, so then that's going to be x plus 3 times x minus 3. Minus, and then one thing that we might want to do is turn this into an addition problem instead of subtraction, because I don't want to forget to distribute that negative later on. So I'm going to put the minus up here and then change that to a plus sign. Okay, so then we're going to say plus negative 4x over x plus 3. And then that's how we want to write our problem. Okay, now what's our LCM going to be now between these three denominators? Well, I got to multiply by an x plus 3 to get rid of this fraction. I got to multiply by x minus 3 to get rid of this fraction. And if I multiply by those two things, great, that gets rid of the big one too. So like we talked about on the front page, this big thing ended up being that times that. Okay, so it's not always going to happen, but it often does for these problems. So then what's the LCM? X plus 3 times x minus 3. We're writing it, of course, in factored form. Okay, and then identify the restrictions. That's something we want to look out for. In other words, what can x not be at the end of the problem? Well, it can't be -3 and it can't be +3. So x not equal to -3 or 3. So we got to keep that in mind. All right, now we can start solving. So we want to multiply everything by the LCM. So these problems do have a lot of writing, but hopefully they're not too complicated. We want to multiply by x plus 3 times x minus 3. Plus 3 times x minus 3. Now you could put x plus 3 times x minus 3 just once and put parentheses around your whole problem. But I like it written out separately. That way you can cancel out individual things and you don't have to memorize so much stuff. Okay? So even though it's more writing, it works out a little bit nicer. All right, so over here, the x minus 3's cancel. And we get 6 times x plus 3, which is 6x plus 18. Equals, here, the ugliest looking fraction works out the nicest because all this stuff cancels and I'm just left with 8x squared. And then plus Here the x plus 3's cancel, and then negative 4x times x minus 3, which is why I distributed the negative earlier. So I remember to distribute a negative 4x. Gives me negative 4x squared. So this plus should actually be minus, but it's okay. We can just put negative 4x squared plus 12x. All right, so there's our problem, and now we have no more fractions, so that's good. All right, let's see. I want to set my equation equal to 0 since it's a quadratic equation. And let's move everything to the, actually we'll keep it on this side, because if we could just combine like terms right here, x squared plus negative 4x squared, in other words x squared minus 4x squared, we get 4x squared. So we'll leave everything on the right side of the equation. So let's bring this stuff over to the right side as well. So we want to subtract 6x from both sides and subtract 18. Okay, and then when we do that, we get 0 on the left side of the equation. On the right side, we get 4x squared. And then 6x minus 12x is plus 6x minus 18. And then, of course, that equals 0. I'm going to put the 0 on the right side just because that's where I'd rather see it. Okay. Now, like I said at the beginning of this video, what's the nice thing about an equation? Well, you can do anything that you want to it. Now, I can't divide everything by 4 and completely get rid of my leading coefficient, but can I divide everything by 2 and at least make these numbers smaller? Sure, and that's going to make it a lot easier to factor because there's going to be a lot fewer combinations we got to look at. Okay? And again, I don't have to just factor out a 2. Since it's an equation, I can actually divide everything by 2, including the 0, and then I get 2x squared plus 3x minus 9 equals still 0. Okay. All right, now let's see, can we factor this equation? Let's try to factor this thing. If you don't want to try factoring, you can use the quadratic formula. Well, let's see if we can do it by factoring. So if we can factor this thing, it's going to be 2 binomials equal to 0. The negative here shows us that our signs have to be different, so I got to multiply a positive and a negative to get a negative number. I got to have something times x here and something times x there. And what's going to go in front of the x's? Well, factors of 2. So it has to be 1 and 2. What's going to go here and here? Well, factors of 9, so either 1 and 9 or 3 and 3. Okay? And is there any way that I can get a difference of 3 using these numbers? So let's see. Yeah. These right here. 1 times 1 is 3. 2 times 3 is 6. 6 minus 3 gives me 3. Okay, so we can do it. Let's see, our bigger product needs to be positive. Well, first of all, 3 and 3, so I can just stick a 3 here and a 3 there. And then I want to multiply the 2 with the positive 3. Since the positive 3 on the inside, the 2 needs to be on the inside, and the 1 would go there, which we don't need to write. So anyways, now we have our answers. Okay? Sorry, we have our factors. And then our answer is going to come from the values of x that make these factors come out 0. So when are these two factors going to equal 0? When x is negative 3, and when x is, this would be positive 3 over 2. Okay, so then are those our two answers? No. Why not? Oh, because we said negative 3 can't be an answer. Okay, so we got two answers, but only one of them works because this gives us a denominator of 0. So our only answer is 3 over 2. Okay, so a lot of times when you get two answers, only one of them is going to work. So make sure you check those excluded values. All right, and then the last problem is kind of just reminding us of a shortcut that we learned, or I think we used it quite a bit in math too. If we have a fraction set equal to another fraction, well, what's one shortcut to solving this thing? Because I can do what we've been doing. I can multiply both sides of my equation by 2x plus 5 and by 11x plus 8. That will work still. Okay, but like we learned in math too, if we have a fraction like a over b equals c over d, my answer is going to be a over d equals c over c. In other words, I can cross multiply. So we'll get a problem like this one. Let's zoom in. It's written kind of small. Rather than multiply both sides of my equation, I can just cross multiply, which you end up with the same thing. Let's just do it that way. I'm going to just refocus real quick. Okay, so if I cross multiply, 1 times 11x plus 8 is 11x plus 8 equals x times 2x plus 5 gives me 2x squared plus 5x. Okay, so after one step, we have no more fractions. So again, it's the same thing really as multiplying both sides by a bunch of stuff. It's just, less writing, and it's easier for people to remember usually. Okay. All right, so here to solve this, let's move everything to the right side so I can keep my x squared term positive. So then I want to subtract 11x and subtract 8. And then this stuff is gone, and we get 2x squared minus 6x minus 8 equals 0. Doesn't matter what side the 0 is on, I just like it on the right side better. Okay. Now, like we did in the last problem, I don't want to factor something with a leading coefficient if I don't have to. Let's divide everything by 2. And this is going to make this problem a little bit easier for us. Even if we're going to use the quadratic formula, we can still do this first. So we get x squared minus 3x minus 4 equals 0. So then we get, when we factor this thing, let's see, our signs are going to be different. So plus and minus, got to have x and x to get x squared. And then what multiplies to 4 has a difference of 3. 4 and 1, the bigger one's negative, so minus 4 plus 1. Okay, so then finally we get our answers of x equals negative 1 and positive 4. Do both those answers work? Sure. Neither of those are going to make these fractions come out 0. Okay. Now, let's go back to a problem on the front page real quick, and then we'll wrap up these notes. And you don't even have to write this down if you don't want to. You might not even have space. But if we get a problem like, let's do the easier one, like number 2. There it is. Okay, so we got 5 over x plus 7 over 4 equals negative 9 over x. Well, since we have two parts, two fractions with the same denominator, can I combine those like terms? Sure. For example, I can, let's just move the negative 5x over. I can subtract negative 5 over x from both sides. And then that's going to cancel with that. And then I get 7 over 4 equals, and then negative 9 over x minus 5 over x, since they have a common denominator, just add the tops. So negative 9 plus negative 5 is negative 14 over x. Okay? And then now I went from this thing with 3 fractions to 2 fractions. Okay, and then now, how can I solve this? Well, I can cross multiply. So 7 times x, I get 7x, equals 4 times negative 14 is negative 56. Okay, and then divide both sides by 7. And we get x equals negative 8. Okay? Or we could have even thought up here, how can I get this numerator to match this numerator? Multiply that by negative 2 to get that. So if I multiply this by negative 2, I'll get x, which is negative 8. Anyways, we get negative 8. Is that any different than what we got before? No. Okay, so on some problems, you can turn it into one fraction set equal to another fraction anytime they have a set of matching denominators. Like number 3, we could have done the same thing. Okay? Anyways, hope that was easier than objective 3. If you have questions, please ask me in class. That's the end of these notes.